Nothing? A what? Dance off? Oh, nice. What type of dance? Like just freestyle? No tap? Ballet? Irish? Step dance? No? Okay. So mainly sticking to ballet? Or are we talking like Dancing with the Stars type stuff? Wow. Lyrical? Like you sing and dance or no? Okay. Very talented, man. Good luck. Anybody else? It's hard to top that one, but great, great. Yep, all you kids at Tulip Fest. Good. Yep. I don't want to know what goes on there. All right, so here we go. Good to hear. Good to hear everyone's got busy weekends. Everyone else just in the corner of your rooms. Wishing you had somewhere to go. All right. Find the area of this regular polygon that's been inscribed. It's got a radius of 4 centimeters. All right. A, it's a quadrilateral, and it's regular. Put those two together. What do you have? It's got to be a square. Yep. In this case, got to be a square. If it's a quadrilateral and it's regular. Radius is 4. Go ahead. Draw in a radius that you think would be helpful in this diagram. I know there's a lot you could draw in. Hey, let's draw in this one. Sure, that's 4. I don't know if it's going to help you or not. Okay, I don't know if it's going to help you. Where would a radius drawn in be helpful for you guys? Probably one that connects it to one of the vertices. So that's got a radius of 4. What's the area of a square? Length times width. And what do you know about the length and the width of a square? Same. Can you help me find it now? Can you help me? There's multiple ways we could do this. How can you get me to a side of the square? What's up, Rico? Oh, whoa, wow. Look at this kid. Okay, so draw on the rest. So that's also going to be 4. That's a right angle because it's a square. And it's also a right angle because inscribed angle drawn to a semicircular diameter. Yep. And we're saying 45, 45. Or you could do what as well? We could also do Pythagorean Theorem, yes. Is everyone all right so far? One way we could do it. Sure. All right, so let's go 45, 45, 90. X radical 2. Ooh, tough spot to be on a 45, 45, 90 triangle. What side am I given? The 8, and that's across from the 90. Yikes. How do I get to one of the sides across from the 45? How do I go to the left on this chart? Let's start it off with 72, 38, 37. I'm stubborn. 42, 39. I don't care. 39, 2 in a row. 30. Okay. Okay, I'm 1. Ha 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 ha! You random generator. 27. There we go. How do I go backwards? Well, here you go. How do I go from here to here? Multiply by? Okay, so how do I want to go back? Okay, so this will be 8 divided by radical 2. Hopefully next year you take this lesson with you to your Algebra 2 teachers. Can't have a radical in the denominator. How do I get rid of it? Multiply top and bottom by radical 2. 8 radical 2 over what's on the denominator? Okay, can you reduce that any further? I hope you can. That'll be 4 radical 2. Okay, so there's a side, 4 radical 2. So the area is going to be 4 radical 2 times 4 radical 2. (16 times 2, also known as 32 square centimeters. We okay getting to that point? Because now what happens if I change it to a hexagon? You're not going to be able to just draw in that and get a 45, 45, 90 out of that. Okay, we got to come up with some other way. We all good here? All right, let me introduce you to a couple things here. You guys have all these drawn in, right, from the center? Yes? On your paper, you can see those? Okay, because I can't see a thing. All right. Let's talk. You guys know a radius can only be found in a circle, so you think can only be found in a circle, okay? Well, I can also draw a radius in one of these polygons, okay? Radius can be drawn from the center of a polygon to one of the vertices, okay? A radius. And just like a circle, what do you think you know about? I know about all these radii. They're all congruent. So I end up making, in this case, 6 what type of triangles? 6 isosceles triangles, okay? We're actually going to get that a little bit more exact right now, all right? So classify this regular polygon. It's a regular hexagon. I'm not ready to fill in the type of triangles for them because you guys think it's isosceles, but it could be a little bit more. I'm going to ask somebody right now, can you find me these angle measures right now? Okay, because these are all congruent triangles, so these are all congruent angles. Can you tell me what those angle measures must be then? If I have 6 of them and they're all congruent. When you're ready here, 5, what do you got for me? All 60 degrees. Okay, all 60 degrees. You guys told me they were isosceles, right? So what do you know about the angles across from the congruent sides? They're also congruent. Can you find those angles for me now? And reclassify each triangle from isosceles to something different. 4, what's going to be the angle measurements for these? I know they're congruent. 60, right? So can you reclassify these triangles? They're not isosceles. I can say they're equilateral triangles. Yep. All right, they're equilateral triangles for the hexagon. Now let me introduce you to a new segment. Can you guys take one of those triangles for me and from the center draw a line that is perpendicular down to the side? From the center, draw a line down that is perpendicular to the side. I'll let you try to pronounce this bad boy. That perpendicular segment you just made is called the... Anybody want to try to? Apothum? Apothum? Is it like saying opossum? No, it is not opossum. It is just apothum. All right, it is not opossum. It is apothum. Or apothum, I've heard before. All right. Again, the apothum is the perpendicular segment drawn from the center to the side. This is going to be very important now because, take a look. I don't know if you guys remember from our triangle unit, but we had a theorem that says if I have an isosceles triangle and I draw the altitude, anybody else remember what the altitude, almost choked on my gum there. The altitude that would have been good, huh? The altitude acts as, in an isosceles triangle, the altitude also acts as an angle bisector, which means this 60 is being cut up into what? 30 and 30, All right, it's also acting as a median, which means what? It's doing what to this full side here? Bisecting it. And that's important because, especially in this hexagon, when we deal with it, that's going to be 30. Guess what this is going to be down here? 60. And look, it's one of our favorite types of triangles, 30, 60, 90. So can anybody come up with a way to find the area of this hexagon? If I gave you some values, could you find the area of that hexagon? Even though you have no idea what the formula for a hexagon is. Is there a way you could come up with the area for that entire hexagon, even though you have no idea what the area formula for a hexagon is? What's up, Katie? Yeah, absolutely. I could take, what do you mean, this one right here? Okay, I could take this area right here, 1/2 base times height, 1/2 base times height, and then I'd have what? If there's 2 of these and there's 6 triangles, I got 12 total, right? So I can multiply by 12. Or, I don't know if anybody else, could I find the area of just one of the whole triangles? This would be your what? That would be my height drawn to the base. Could find 1/2 base times height, multiply by 6. Okay? And that's what we're going to end up doing eventually for all these regular polygons. We're going to make triangles out of them, find the areas of the triangles, and multiply by how many there are. Trapezoids. Oh, you mean here and here? And then, see that now I have a problem with the height though. Because the height's got to come from one of this. This wouldn't be counted as the height because remember the height's got to come from a vertex, right? In the trapezoid, so it would have to come from here down. So that might be a little tough. Okay. We okay what an apothem is because we're going to be starting to use it and start talking about it a ton. Okay. Before we get into finding the areas, I need you to be able to find angles for me. So each polygon's regular. I drew a radii or multiple radii in and an apothem. Find the measure of each angle. Okay, so I have a square here, regular polygon for a square. I'm looking for the measure of angle 1, 2, 3, and 4. And remember, the apothem now is not only perpendicular, it acts as a bisector, it acts as an angle bisector. So let's start with the easiest one up here, which I think is angle 4. Okay, angle 4. There's 4 of them. They're all congruent. Let's start there. 21, any thoughts on angle 4? 90 degrees, if you're wondering how he got it, he took 360 divided by 4 and got 90. All right, so I know all those full angles are 90. Apothem acts as an angle bisector, which leads me to angle 1. 2, what's angle 1? 45, it's an angle bisector. So that's going to be 45. Let's go to angle 2. 24. Remember, angle bisector. So the one next to it's 45. That's already 90. So angle 2's got to be 45. And then how about angle 3? 4? 90. It's right. Supplementary to the 90 I already gave you. Yep. Okay. Any issue on that regular polygon? All right. Go to 2 then. How about that one? 5, 6, 7. Now it's a regular triangle, an equilateral triangle. So 5, 6, 7. Start us off with angle 7. Yeah, 360 divided by 3, 120. Yep. I divide by how many angles there are, which would make angle 5 what? 7? 60, because it gets bisected. So that's 60. And we just went over before. What do you have for the remaining angle? 25? 6 there. 30. Okay, we all good? Questions? And again, how could you find the area? Okay, we could do length times width, like we did at the beginning of class. Or now, what could we do? Find the area of one triangle and multiply by 4, multiply by 3. All right? Questions, comments? All right, let's actually start finding the areas then. Enough talking. I'm going to give you a formula. I'm going to regret this. You can find the area of each triangle, multiply by how many of them. I'm fine with that. I am fine with that. Or I'm going to give you a formula if it's easier for you to use to find the area of any regular polygon. I don't care how many sides it is. It's going to be 1/2 lowercase a, lowercase p. Let's see if you guys can guess what each letter means. 1/2 AP. And I always tell the joke, everyone stare at the A and the P next to each other, because that might be the only time some of you see those letters next to each other. AP. Okay. Sorry, too harsh. Some of you don't get it, but you'll figure it out later. What do you think for A? Something we've talked about, I've introduced today. That's the apothem length. And P is going to be tough. Something that starts with P you could find for these polygons. There you go, I'll give you the first letter. Any guesses yet before I reveal a second letter? Perimeter. Yep, the perimeter of the figure. Oh, you kids are clever. Okay. Here's my regular pentagon. Each side is 7.2 feet. And you could go all the way around, and a radius of 6.1. Remember, the radius starts at the center to one of the vertices. 6.1 feet. What's the area of this regular pentagon to the nearest tenth? All right, just can you guys just do me a favor? Just have a calculator in your hand right now. Drop your pencils and pens. All right, and just help me out. Let's go through this whole find the area of a triangle, multiply how many of them there are, okay? If we can do it that way. So I'm going to draw in one of the triangles by drawing in another radii. Okay, can I find the area of this triangle that I've drawn right now? All right, I'm not too sure here, but let's see. If I draw the height in, and again, just let you help me out. That's all I'm asking. You help me out right now. So the area of this triangle is 1/2 base times height. We're all in agreement. What's the base if I just drew that height in? 7.2. Okay, how could I find the height? Well, could you find out what one of these angles are right there? 360 divided by? 360 divided by? 5. Everyone, yep, go ahead. 360 divided by 5. What's the full angle? 72 degrees, yep. And what did we've been saying all day today? What is this height, aka the apothem, doing to the 72? Bisecting it, right? So what's each angle here? Is that a 30-60 or a 45-45 that we're familiar with? No. So it's going to be kind of tough to find the height. We'll talk about it on Monday, but everyone see how it's going to be tough to find that height because it's not something I'm used to, 30-60, 45-45. Is there a way you could do it? Yes, but we'll talk about it Monday. But does everyone see? I'm not really going to find the height too easily. We all in agreement? We okay with that? Yes? No? We sure? Madeline? I was going to get there eventually, but thanks for blowing that up for me. That's fine. I just wanted to showing you guys that maybe finding the area of the triangle is not the best idea. Okay, so can we try to use 1/2 AP? Because this is a regular polygon. 1/2 AP. And yes, some of my thunder was just stolen, but it's fine. Perimeter for me, real quick. We can at least find the perimeter right now. Find the perimeter. 11, when you're ready, find the perimeter. 36. How'd you get it, just in case people don't know? 7.2. It's regular, which means all sides are 7.2. Okay, now the apothem length. Okay, now to the apothem length, which is the segment we just drew in here that's perpendicular. Okay, Madeline did say Pythag, but where is she getting that from? Where is she getting the Pythag from? I do see a right triangle. I do know one side is 6.1. Well, where the heck's the other side coming from, Ella? This is also a median, which bisects that side. So if that's 7.2, what's this other side? What's each side here? It'll be 3.6, yep. So now I can say, do Pythagorean Theorem and say 3.6 squared plus the apothem squared equals 6.1 squared. And should we be rounding anything yet? This is not the final answer. You guys are getting what? The square root of 24.25? Okay. I'm going to write that into the formula. If you want to write the full decimal, go right ahead. 24.25. Again, you guys want to write the full decimal, go ahead. And rounded it to the nearest tenth. 16?
88.6.
Got any units there, stud?
Feet squared.
We okay there? So now going back to my original point, could you have find the area of this triangle 1/2 base times height multiplied by 5? Yep, you could. Okay. Yep. Anything right now using 1/2 AP? Because I want you to try some on your own here in a second. Okay. Last one I'll do with you, and then you got 5 and 6 with people you want to work with. Okay, find the area of the equilateral triangle given the radius. Leave your answer in simplest radical form. All right, I know you could use 1/2 base times height if you want to. That's fine. I just want to get more work using, it is equilateral, so that tells me it's regular, so I can use 1/2 AP. I just want to get some practice with that. So one radius is 4. Ooh, I don't have perimeter or the apothem. Okay, draw in another radius for me. Draw in another radius so I create a triangle inside. So draw another radius. Somebody find me that angle measure I've just created by drawing in the other radii. What's that angle measure I just created? 7? 120. 360 divided by 3. Draw in the apothem. Go ahead, draw in your apothem so I can find it. Who just told me that angle? Evan, what was the angle again? Hey, ready? That 120 is about to be split into 60 and 60. Oh, what type of triangle are you working with? 30, 60, 90. Let's roll. Where's the 4 across from? 14. Where's the 4 across from? 90. What must have been across from the 30 then? You're going backwards. Be careful. 2. Nice job. Hey, so the apothem is 2. What's across from the 60 then? 2. What's across from the 60? 2 radical 3. Nice job. I need someone to help me with a plan to find the perimeter of this whole triangle. The entire triangle. Can somebody come up with a plan? Help me, your classmates out. How can I find that perimeter? 27. Want to roll through it here?
2 radical 3 times 2. Take that and times by multiply it by 3.
So multiply it by 6. Right? Yeah. That's fine. Yep. Because remember, that's bisecting. That's a median as well, not just a altitude, but it's also a median. So this is also 2 radical 3. So the perimeter would be 2 radical 3 times 6. So my perimeter would be 12 radical 3 times a half. Simplest radical form, though. Simplest radical form. Five, simplest radical form. Just 12 radical 3, yep. Because the 2 and the 1/2 create 1. No units, so I'm not going to put any on. All right, you want to get with people you want to work with here to try these next two? 5 and 6. Go ahead. You can move around if you want. Work with other people, and then I got two Regents questions I want you to try at the end. I'll jot the answers down up here. Three is the entire length of AC, if you're wondering. If you guys want to use 1/2 AP, that's fine. If you want to make 6 triangles and find the area and multiply by 6, that's fine too. You guys are not forced to use 1/2 AP if you don't want to. It's just a different way of getting to it. And you guys will get a new Regents on Monday. Okay? Again, save all these somewhere. Do not just toss these Regents or somewhere you can't find it, because I think we're going to have more days than I actually planned for. All right, we may have about 5 or 6 days to review. So, and I don't know if I told you, but did you guys get those green books last year? Okay, we're not doing them. Okay, I'm actually just going to print you off every exam and give them to you. One, because have you ever experienced how little space there is to write in those things? Yeah, I'm sure you have. Okay, and I don't want you squeezing stuff in there. I want full pages just like you guys have it right in front of you right now. All right. So hey, our favorite unit, circles. Yeah. Go through the givens right now. Mark your diagram with the proper markings. Chord DC is parallel to chord BA. There is a theorem that says if two chords are parallel, something happens, but we'll get into it if we need it. BCD is 30. Find the measure of angle AOB. All right, a lot going on for such a small problem. Angle BCD is 30. What type of angle is it? Inscribed. Can you fill out any more of the chart now? I mean, any more of the diagram? If that's 30, based on what you know about inscribed angles, what else can you fill in? Arc BD is 60. Yep, inscribed angle is half its arc, so that's got to be 60. What type of angle is AOB, the one they're asking us to find? Central. If you knew what arc, we'd know the answer to this problem. What arc would we need to know? Arc BA, yep. All right, well, let's go back to these parallel chord business. Anybody remember the theorem about if two chords are parallel? The arcs in between are congruent. Yes, so up here, which two arcs are congruent? DB and, okay, so that's got to be 60. Let's finish this off. What's BOC acting as? Diameter, so that's got to be 120, which means my angle is 120. I think you got 4 big problems tonight.